Hello. Okay, so we're going to go over what the graph of tangent looks like, and we'll do a couple of examples on how to graph it. So to begin with, remember that trigonometry is the study of triangles. Good. So we went from triangles, and then we put the triangles on the unit circle, right? So we've got this unit circle here. We can see all the special triangles that can be placed on here. So then we've got the unit circle, and with the unit circle, we can now take the information on here and plot it onto the graph, just like we did with sine and cosine. So we're going to go ahead and do that with tangent. And with tangent, we're just going to use a couple of special points. So we have basically just this whole right side is what we're going to be looking at. And the right side, if we look here, we have 0 right in the center, right? So if we go in this direction, obviously we got the positive side, and it goes from 0 to pi over 2. And with tangent, we're going to be going on to the negative side as well. So if you think about a coordinate plane, something like this, right, we have 0 at the center, and on the left side we've got negative infinity, on the right side we've got positive infinity. So our tangent graph is actually going to be halfway, and I'll do a little sample of what it's going to look like, halfway on the positive side, like that, and halfway on the negative side, like that. That's kind of what the tangent is going to look like. So what we do is we look at the unit circle, and like I said, we've got this half over here. This is the positive side, so we're going from 0 to pi over 2. And then when we go in the negative direction, it's still the same distance, and so instead of 3 pi over 2, we call it negative pi over 2, right? Because it's still the same distance, just going in the opposite direction. So it's kind of like, if we look here, just we've got a rough graph here. This is going to be positive pi over 2, and then on the opposite side is negative pi over 2. Still the same distance from 0, which is here. Okay, so that's something that you need to keep in mind to begin with, is that it's a little bit different from sine and cosine, because remember with sine and cosine, we would have the coordinate plane, and if it was in standard form, it would start somewhere here at 0, either at the center or at the top, and then we would move towards the right and complete the graph that way. It's a little bit different with tangent because it's going to be centered at the origin, okay? We are going to start graphing at the center, and then what we'll do is we'll move in both directions. You'll see what I mean. But just so you know here, it's going to be a little bit different than sine and cosine in that way. So keeping that in mind, we're going to look at the special points that we'll use to plot tangent. And before we do, we want to think about, how do we actually find a tangent value on the graph? Like if I say, find me tangent of 0, how would you find what tangent of 0 is? Well, remember, tangent is the same thing as y divided by x. So if I were to ask you what is tangent of 0, you would come over here to where our angle is 0. You look at the y value, and you see the y value is 0. You look at the x value, you see that it's 1. So you do 0 divided by 1, which is 0, okay? So this is the information that we're going to be plotting, and I'm going to do that for a couple of points here. So for 0, we know we've got 0, okay? And then I'm going to just skip right on over to negative pi over 2, okay? Now negative pi over 2, my y is negative 1, and my x is 0. So I've got negative 1 over 0. Well, remember, number up top 0 at the bottom means it's undefined. Okay, so we're going to plot that in just a second, but we're just calculating the values. So we've got undefined at negative pi over 2. We've got 0 here at 0. And then I'm going to skip over to pi over 2. Actually, I just realized I missed one here. We're going to look here at, in the positive direction, it's 7 pi over 4. But actually, if you go in the negative direction, it's negative pi over 4. And that's because if you look here, it's the same exact distance as positive pi over 4. So we need to include that one as well. Our y value is negative root 2 over 2. And then we divide that by positive root 2 over 2. And well, that's just going to equal negative 1. Okay, so we've got a negative 1 value at negative pi over 4. And then over here at pi over 4, very similar, our y value is root 2 over 2. We're dividing that by root 2 over 2, and that gives us 1. And last point here, we've got at pi over 2, y divided by x is 1 divided by 0, which is undefined. Okay. So we've got 4 points here, or 4 angles that we've calculated. So this shows us that the tangent graph is only going to have 4 special points that we need to plot. Okay, so I'm going to go ahead and start to put these on the coordinate plane. So remember, the angles are what goes on the x-axis. Just like sine and cosine, our angles were always on the x-axis. And then our tangent value is what goes on the y-axis. So we can start with the angle 0, just because that's the center point. This is what we always want to start with. Okay, so that means we're starting at the origin. And when the angle is 0 here, our y value is also 0. Our tangent value is 0. So I'm going to plot the point 0, 0. Let me do this in a different color so it looks prettier. No, so you can see it a little more clearly. Okay, there we go. And then we're going to move on to pi over 4. So that's going to be my first step to the right, because this is the positive side, remember? Positive side, negative side. Okay, so positive pi over 4. When I look at the angle, what is my tangent value? It's a 1. So that means my y value for this point is going to be 1. Okay, next step is going to be pi over 2. So I'm going to put that step here. And remember, pi over 2 is undefined. So that means there's actually not going to be a point. Whenever our function is undefined, we have an asymptote. So I'm going to draw that dashed line there to represent the asymptote. That means our graph is not going to cross that line. It's going to come really, really close to it like this, but it's not going to actually cross it. So we've got half of our tangent graph now. What I'm going to do next is I'm going to do the negative side. So starting here, actually I should say here with negative pi over 4, that's going to be my first step on the left side. And really symmetry is key here, right? So we see the symmetry happening. But look at our tangent value. Our tangent value is negative 1. So we're going to have a point down there at negative 1. And our very last step is going to be negative pi over 2. That's this one right here. And remember, that one was also undefined. So we've got an asymptote there. Okay? And this is it. We'll repeat the pattern in just a second. All I need to do is connect the dots and see how the dots are going down, middle, up. I just want to connect them that way. And try to make it, see, I kind of messed up. The graph, you kind of want it to be going towards the asymptote. So let me draw that again, make it a little bit nicer. Something like that. Okay, so I'm not an artist, but that's what tangent should somewhat look like. So that's our standard tangent graph, actually. You'll notice some of the key features. We've got two asymptotes, and these two asymptotes, if you were to actually measure the distance, that distance is the period of our graph. So we're talking distance, right? So if this from here to here is 1 pi over 2, and from here to here is another 1 pi over 2 distance, then the total period, if you were to add these together, 1 pi plus another pi equals 2 pi's over 2, which those 2's cancel and give us pi. So our standard tangent graph has a period of pi. That's a little bit different from our sine and cosine graphs. If you remember, sine looked like this. Its standard graph had a period of 2 pi. Same thing with cosine. That means it took that total distance in order to get all of the points in a standard graph. So tangent is a little bit shorter. And so what that means is, if you look at our chart here, you find the period differently. And so this is going to be super important. Almost everything is going to be very similar to finding all the values for sine and cosine, but this is where it's going to be different. Instead of 2 pi over b, the period is going to be pi over b. Okay, so that's a big difference here. Now let's look at the standard form. You've still got A, B, C, and D, so you still need to be able to find that. It's still in the same exact position, so that's not going to change from sine and cosine. You still need to find your amplitude. Your amplitude is still going to be A, but your amplitude looks a little bit different in the graph. So remember, before we knew that the amplitude was the distance from the middle to the highest point, and that was our amplitude, or the middle to the lowest point. It'd be the same because, well, symmetry. So if we come to our tangent graph, we don't have a highest point or lowest point because our graph is continuous in both directions. So what does the amplitude represent? It actually represents the distance for our key points here. So we have a center point that's always going to be on our midline. Okay, just like sine and cosine, the standard graph has a midline on the x-axis, and then it might move up or down. And then we have our amplitude on the y-axis. Okay, so very similar kind of setup on the axis. What's different is when you actually go to plot the points and connect the dots is where it changes just a little bit, but still very similar concepts here. Okay, the steps are also going to be period divided by 4, just like sine and cosine was. It'll be a little different when you put it on the coordinate plane, but we'll see an example of that. And then the vertical shift, again, is the same thing as your midline, just like sine and cosine. And it's also just going to be d like before. So little changes here and there, still very similar to sine and cosine. Okay, so that's our basic understanding of the standard form of tangent. We're going to graph the standard form of tangent again, but just looking at finding its key parts. So we've got this example, y is equal to tangent x. So we're going to work on finding A, B, C, and D, just as a refresher here. So remember, A is whatever's in front. If there's nothing in front, then A is 1. B is whatever's multiplied to x. If there's nothing in front of x, then b is 1. C is whatever is added in parentheses. If there are no parentheses, then your C is 0. D is whatever is being added without the parentheses. If there's nothing being added or subtracted, then your D is 0. Okay, so that's our standard graph there. We're going to find all the parts. So remember amplitude. Actually, you know what I forgot here? Still want it to be the absolute value of A. So same as sine and cosine. Our amplitude is just going to be 1 because our A is 1. Okay. Our period, okay, this is where it's different. Remember, instead of 2 pi, it's going to be just pi divided by B. And my B is 1, so that becomes just pi. Next, we want our steps. Our steps will be period divided by 4. If my period is pi, then my steps will be pi divided by 4. And let's go ahead and find our vertical shift. And that's just our D. Remember, D is 0, so there we go. Okay, there's all the parts that we need. So now I'm going to come on to the side here and start my coordinate plane. So what I will begin with, I always like to start with the x-axis. Sometimes that's the hardest, so I like to just get that over with. Let's do blue. So our steps are pi over 4. That means I'm going to come on here, and with tangent, you're only going to do 2 steps to the right and then 2 steps to the left. And then, of course, you've got your center there. So that's how many points we actually have to plot, or how many characteristic for the tangent graph that make up the tangent graph. So that's kind of what our standard should look like, and then your steps will fill in depending on what your steps are. So the steps are pi over 4, so that means I've got 1 pi over 4 and 2 pi over 4. And of course, 2 pi over 4 simplifies to pi over 2. Okay, that's the right side. And nice thing about symmetry, now you just do the negative of that on the other side. Okay, that works perfectly fine when it's centered here. So we've got our steps down. My amplitude is 1, so 1, and symmetry, -1. All right, our midline is at 0 here. So that's why our amplitude is just going to be up at 1, down at -1. Cool. We got that set up. Now we get to just go ahead and get started. So we always start with the center point. At least I do. I guess you don't really have to, but I like to start at the center point. And the center point is always going to be on your midline. So you technically start middle, and then you go up. So then 1 step over, and you go up. So you have a point right there. Okay, so you go middle, up, and then asymptote. So that's the right side pattern. The left side, you're going to go, if you're at the middle, you go 1 step over, you go down. All right, and then 1 step over, asymptote. Okay, and that's the pattern. Depends however you want to remember it. You'll find that it's a lot easier when you start getting these midline changes to start at the middle and then go middle, up, asymptote, back to the middle, down, asymptote. That's the pattern that I like to use. If you want to go asymptote, down, middle, up, asymptote, by all means, try that if that works for you. You'll see with more practice, whatever makes the most sense to you, do it. So Oh, most important thing probably is to connect the dots. Again, I don't know why this is not coming out very pretty, but that's what the tangent graph should look like, okay? So you always want to make sure you label everything like you see here, and that your points, each point needs to have its own step, and each asymptote needs to have its own step. Okay, so there's one example. Let's try another example. So we've got a bit of a period change. We'll see that happening here. Let's go ahead and find A, which is going to be 1. My B, I got a B here, is 2. No C and no D. Okay, amplitude, 1. Period is pi divided by B, so pi over 2 this time. My steps are going to be my period divided by 4, which is the same thing as my period times 1/4, which is going to be pi over 8. That's fun. Okay. Now, what comes next? Vertical shift, if we have it. My D is 0, so we've got no vertical shift. Cool. So our midline is going to be 0. Okay. That's helpful to note. And let's get to graphing. Okay. So remember, you've got your center. You've got 2 steps to the right, 2 steps to the left. And then you slide. No, just made me think of like the cha-cha slide. Anyways, okay. We've got our steps there. And now we're going to label the steps. So my very first step on the right side, the positive side, is going to be pi over 8. And then my next one will be 2 pi over 8. That's going to simplify. 2 over 8 simplifies to pi over 4. Cool. Right side is done. Now to the left side. Negative pi over 8. Negative pi over 4. All right. We got our steps down. Now we need our midline. Our midline is 0, so we're good here. And then our amplitude is 1, so 1 and negative 1. Okay. Notice the distance here, right? It should always be equal. All right, so we've got, that's the main setup. Now we will start the middle. We got a point at the middle, and then we go up. 1 step over, we go up. 1 step over, we got an asymptote. Okay, back to the middle. 1 step to the left, we go down. 1 step more, we got an asymptote. There we go. Connect the dots. Oh, that was a nice one. Okay, there we go. Tangent 2x. Not too bad, right? Let's do another one. And feel free to pause the video. Maybe try this on your own, see how that goes. I'm going to go ahead and start to find A is 1, B is 4, C is 0, D is 0. Amplitude is 1. Period is pi divided by B, which is 4. And my steps are going to be pi divided by 4, or pi over 4 divided by 4, which is the same thing as my period times 1/4. And that's going to be pi over 16. Okay, not the prettiest, but it's okay. It's easy. We got this. Vertical shift, 0, because that's my D. And that's going to be my middle. Okay. Let's graph it out. So we've got our middle here. 1, 2 steps to the right, 2 steps to the left. Label it. My steps are pi over 16. So first step is 1 pi over 16. Second step is 2 pi over 16. 2 over 16 will simplify to 1 over 8. So there's my right side. Just do the negative of it on the left side. That's my steps. My midline is 0, so I know that this axis is my midline. My amplitude is 1, so up 1, down -1. Okay, there's the setup. Now let's graph it. And we've got middle right here. We go middle, up, asymptote. Back to the middle, down, asymptote. Connect the dots. There's our tangent graph. This was fun. Let's do another one. My A is 2, B is 1, C is 0, D is 0. So my amplitude this time is going to be 2. It's a little different there, changing things a bit. But now we're going back to a period, a standard period. Pi divided by 1 is just pi. And my steps are going to be pi divided by 4. Vertical shift, still don't have a vertical shift yet. We're easing our way into it. So there we go. So let's see what happens with this amplitude change. Our steps come first. We've got the middle, 1, 2, 1, 2. Steps are pi over 4. And then 2 pi over 4. That's going to simplify to pi over 2. And copy the negative on the other side. Okay. We need our midline, which is at 0, so there's our midline. And then our amplitude is 2, so up 2, down 2. Now we get to plot it. So we start at the middle. Next step we go up. Next step is an asymptote. Pretend that actually lined up here. And then we go to the left. So we go down and then asymptote. Okay, so that's the only change, is that we know that it's getting stretched out a bit because our amplitude is changing. Okay. All right. We got another amplitude change. See if you can pause the video and try this on your own. I'm going to go ahead and find my A, B, C, and D. A is 5, B is 1, C is 0, D is 0. My amplitude is 5. Period is pi divided by 1, which is pi. Another pretty standard period. Steps are going to be pi divided by 4. And my vertical shift is still 0. And let's plot it out. So, center, 1, 2, 1, 2. Steps are pi over 4, 2 pi over 4, which is pi over 2. Go to the negative side. My midline is at 0. My amplitude is 5, -5. Okay, now we plot it. Middle point, up, asymptote. Back to the middle, down, asymptote. Connect the dots, and there's tangent. Okay, let's try this next one. If you want to pause it, try it on your own. We got a couple of changes here. A is 3, B is pi, C is 0, D is 0. My amplitude is going to be 3. My period is going to be interesting. So we've got to take pi. Oh, that's weird. Fix that. And then we divide it by B, which is pi. So pi divided by pi is 1. We've got a period of 1. My steps are the period divided by 4, so my steps are going to be 1/4. And then we've got our vertical shift, still 0, d is still 0, okay? Just because our period looks a little different, doesn't have pi in it, doesn't change anything. We've got center, 1, 2, 1, 2. My steps are 1/4, so this first point is going to be 1/4, and then you got 2/4, which is 1/2, -1/4, and then -1/2. My amplitude is 3, so I'm going to go up 3, down -3, and there's the setup. Center point, up asymptote, back to the center, down asymptote. Connect the dots, and there we go. Okay, I think this may be our last one. Yes, it is. Let's do it. You want to pause it, try it on your own. Do that. A is 4, B is 3, C is 0, D is 0. Amplitude is 4. Period is pi divided by B, which is 3. My steps are my period divided by 4, or my period times 1/4. That's going to be pi. 3 times 4 is 12. Yes, it is. There's my steps. And vertical shift, 0. Did I not include a vertical shift? Let's do a vertical shift. Let's make it a +1. Okay, this is going to be interesting. So my D is now 1. So my vertical shift is now 1. Let's see what's happening now. Let's do our coordinate plane. Here we go. Let's start with the steps. I'm going to mark them just the same. So we've got a center, 1, 2, 1, 2. My steps are pi over 12, so this is going to be pi over 12. And then you've got 2 pi over 12. 2 over 12, that simplifies to 1 over 6. So pi over 6 is that final step there. Do the negative on the other side. Okay. So there we have it. Now we've got a midline. Remember, this is our new middle is going to be at 1. So I've got to go here, and you can plot out a midline if you'd like. So there we go. There's our middle. And our amplitude is 4. So just like sine and cosine, you've got to count it out. So we got to count 1, 2, 3, 4 up from the midline. So our highest point here is actually going to be at 5. And then we count 4 down. So 1, 2, 3, 4. And that's going to bring us down to -3. Okay, so this is going to be the kind of like your highest point here, and then this is our lowest, and then this is our middle, right? Or you can say this is our up, and this is our down. All right, so there's the setup. That's the only real change here. So now when we start at the center, we've got to start here, right? Because we're still at this like middle point right here, middle step, but you got to start it in the middle line. So we've got that. You go to the right, which goes up, and then asymptote. Go back to the middle. Your next step is going to go down, and then asymptote. Connect the dots as best as you can, and there's your graph. So this one had that vertical shift. It just changed where that middle point was, but the placement of everything is still the same, right? So to the right, you still go up, and then another point to the right, asymptote. Middle, go to the left, it's going to be down, over another asymptote. Okay, and that's how we graph our tangent graph. Hope you enjoyed it. I had a lot of fun doing it.